I'm Erica Zavaleta, and this is Ecosystems of California. And today we're visiting Younger Lagoon Reserve with Beth Howard, who's the reserve manager. Beth, can you tell us a little bit about the reserve and what you do here?
Sure. So Younger Lagoon Reserve is part of the University of California's Natural Reserve System. Our system was started in the 1960s to protect different ecosystems and habitats across the state of California and to use those places for teaching and for research. This reserve has been here since 1986. It's 72 acres in total. It encompasses beach dunes, freshwater marsh, saltwater marsh, grasslands, northern coastal scrub, and even dense willow thickets. Our reserve, unlike many of our reserves, which are in more remote places, is adjacent to the university's coastal science campus and very close to town, and it means that classes can come out and use the reserve as an outdoor laboratory and living classroom. We also support dozens of undergraduate interns at the reserve every year, either working on restoration projects or on their own research projects. So every day is different. Typically, I look at my role as supporting teaching and research on the reserve and taking care of the land. So in terms of supporting and teaching and research, that could mean anything from assisting with teaching a course that's using the reserve to simply helping researchers cite their projects. And then in terms of taking care of the land, a lot of our time is spent on restoration projects. We have a large-scale project that's trying to restore about 50 acres of former Brussels sprouts fields into native grassland, wetlands, and coastal scrub habitats. So this plant is called beach burr. It has a really spiky seed, and I'm feeling around right now to see if I can feel any. So here's the seed right here. These barbs on the outside of the seed, I think they can help with transporting seeds around, but I think they also help the seeds get rooted down here into the sand. You know, the sand is always blowing around with wind, there's tide coming and washing over, and so this helps the plant establish on the sand. And then the beach burr is really a pioneer plant of the dunes. It has a deep taproot. That taproot helps it stay rooted into the sand. You can see it's out here on the edge of the dunes moving towards the ocean. And then over time, sand begins to start to accumulate around the beach burr. And then it starts to build up these little hills, the dunes, and other plants begin to establish as well, like these morning glories. So we're looking at beach morning glory leaves here. This had earlier in the spring beautiful pink flowers on it, and now a lot of those flowers have gone to seed. And so this is a beach morning glory seed here, and it's a really large seed in comparison to some of the other plants that we have on the dunes.
So that's just one seed encased there in the wow. I mean, that makes sense from an adaptive perspective because it is so hard to establish in these sands. There's so little nutrient availability. I mean, it just seems like you would want to give your offspring a big package of nutrients to get established until you get roots all the way down to some soil.
So this is Deadlia cespitosa. A common name for it is live forever. It's a native succulent. So it looks like it belongs maybe in the desert, but it's native right here to Santa Cruz, Monterey Bay area. And you can see it's making its living growing right now out of the side of this piece of wood. Here at the reserve, we often see it growing out of the sides of cliffs.
So that's pink sand verbena, and that, it turns out, is the first plant from California ever described by scientists. It was collected somewhere here in the Monterey Bay in 1786, and some seeds were taken to Europe, and it was named a few years later by a British botanist based on plants that were grown from those seeds in a garden in Paris. Relatively few native plant-dominated dune ecosystems still exist in California. So even though Younger Lagoon's dunes are small, they're a great example of what this system can look like. So what are the ecosystem dynamics of a dune field like this? The beach supplies sand to the dune. It blows in with the wind. So the most dynamic and mobile shifting part of the dune landscape is in the foredunes near the beach. As you get further back to the back dunes, there's less wind, less movement, sometimes less salt, more of a chance for a greater variety of plants to establish. So there are two patterns of vegetation zonation, or two scales of patterning that we can see here in these dunes. There's a third scale, the whole region of California. You can see shifts in what kinds of vegetation inhabit dunes from north to south. As you get up to the north, there are more shrubs and woody vegetation, but here in the central coast, it's mostly lower herbaceous plants. That's the largest scale of variation. There's this medium scale of vegetation patterning that you can see as you look from the coast back towards the lagoon. Out here we've got these pioneer and really low prostrate growth forms like beach burr and beach morning glory that are able to cope with very low nutrient conditions, a lot of blowing sand and shifting substrate, and maybe some salt spray during certain times of the year. And then as you go back, there are more grasses, woody plants, including more invasive species that are able to establish. At the smallest scale of individual mounds and ridges, there's this vegetation patterning that has to do with different conditions on the windward or coastal side of these mounds, where there's more blowing sand and more wind going over to the backside. And you can see that the mounds themselves have more vegetation on top with sand in between them. A lot of that has to do with the effects that the plants are having on the dynamics of the dune. So plants can do two things to shape the morphology of the dune field. They can trap sand, and they can also stabilize it with their roots. And over time, the plants themselves are causing the mounds to form. And depending on what species colonize them, raising them up higher and making them steeper if they're stabilizing the substrate. Dunes are hard places to live. First of all, there's burial by sand and exposure or excavation by moving sand. They also have to deal with really low soil nutrient availability. There's hardly anything in these sands. There can be really low water availability near the surface because the sands drain really quickly. There's drying out by the wind, exposure to a lot of solar radiation, and then salt carried in on the wind and in aerosols from the ocean. So what are some of the organismal adaptations to this system? Vegetative growth, and for the plants that are reproducing with seed, large seeds and seed structures that help them hold on to the sand. There's a variety of low and prostrate growth forms that do great out here in the dunes but don't compete very well when you get up into higher nutrient environments where more fast-growing and tall species will dominate. And then you've also got leaves that are succulent, they're thick, they may be coated with hairs or with a leathery sort of sclerophilous surface. White hairs on the leaves can prevent water loss, and then some of them are going to secrete salt through their leaves so that they're not accumulating it too fast. Here we are in the back dunes, a couple of 100 meters away from where we just were in the fore dunes near the beach. And the vegetation's changed. It's mostly this plantain that's more of a terrestrial plant growing in an area that doesn't have that mound structure anymore. We're in more of a stable soil zone right now. So we're getting up into more invasive plants and more grassland plants. Here's some shells from a bird egg, maybe a killdeer, which there are a lot of here at Younger Lagoon. So all kinds of animals pass through the dune system. There are some resident things like spiders and ants, but many more things like brush rabbits, shorebirds like the western snowy plover, bobcats, raccoons and coyotes forage in the dunes and on the beach. And then in bigger dune systems than Younger Lagoon, deer and elk can graze on back dune vegetation and will travel through dune systems between the beach and inland meadows. Why does one ecosystem end where it does and another begin there? We have these boundaries that you can mainly see as changes in vegetation. There, the pickleweed ends and this upland grassland begins. Here, the grasses end and the dune vegetation begins. Over there, there's a transition from the herbaceous plants on the dune field to the shrubs and woody plants of the coastal sage scrub. So what are the things that are controlling where one thing ends and the next one starts? In some places, the transition is really sharp, like the line between the water in the lagoon and the pickleweed on shore. In other cases, it's more gradual, like the transition from the beach into the dunes, where you've got no vegetation and then gradually increasing density of just a couple of pioneer species like beach burr. So let's look at one of these boundaries together, the boundary between the lagoon system and the dune system. This is a boundary that's shaped really strongly by physical factors. You've got water And then once you have some somewhat dry soil, it's really salty. So you have pickleweed that's able to tolerate really salty, submerged conditions. And these other grasses up on the uplands can't colonize there because they can't tolerate the salt and they can't tolerate all of that water. Looking at it from the other direction, the pickleweed can't come up into the upland grassland. That's a little bit different though. That's not physical stresses. That's these grasses being more effective competitors for resources than the pickleweed. So the pickleweed's tolerating stresses, and then up here on this side of the boundary, these grasses and sedges are preventing the pickleweed from establishing. Here's a place where the beech morning glory just comes right up to here, and then you've got the coyote brush and the shrubs, and you can kind of see the morning glory. It gets in a little ways and then it peters out. Coming this way, the shrubs come down as far as they can and then they stop. So what are some possible explanations for this transition? If you're thinking of topography, you're onto something. The dune vegetation is mainly growing down here in the flats, and then you've got a hill slope where the woody vegetation kicks in. And so for one thing, sand is moving all the time over the dune field. It can't accumulate on the hill slopes. And so the vegetation down here is able to deal with that constantly moving substrate and that really low nutrient availability in the dune fields. You get up here onto the slopes and sand isn't going to move up there and accumulate, so there's a little bit more chance for there to be developed soils exposed with organic matter, nitrogen, and phosphorus to support the growth of plants that maybe have smaller seeds that need a little bit more of a kickstart from the soils to get established. So again, here's a case where abiotic factors are keeping the woody shrubs off of the dune field, and where competition, biotic factors up on the hill slope, are keeping things like, say, beech morning glory or beech burr from growing further up on the hillside where they would be shaded out by all these woody shrubs.